Hello, I'm not a video blogger. I never expected to share this as a video, so this is going to be awkward, maybe to the point of an embarrassing cringe. I'll do it anyway. Here's a topic that interests me a lot lately, AI. Its role in my work today. I worked in system reliability engineering and IT security, and its role in our lives tomorrow as applied to computing. And I have ideas about the new paradigm they keep talking about. AI dominates the discourse in IT today. I used to be very skeptical about it, and I still am, but at one moment I felt I needed to set aside my political, social, ethical beliefs to better see what our future is. Because one thing is sure, there's no way out of it anymore. There never was. People just keep talking about how AI will change everything. I recently attended this intra-corporate IT conference. The dominant topic was AI, of course. One of the main highlights was how the speed of innovation around large language models suddenly went from years between updates to mere months, even weeks. They say it's important to adopt a new paradigm. At the conference, two workshops attracted me. One was an exercise in prompt engineering. Participants were given a simple Java application, a couple of hundred files only, and asked to massage a prompt iteratively and feed it back into the API in order to trick LLM into detecting all the issues in a huge PR. Most participants had not finished the exercise in time. Those that did mostly failed. The second workshop was about coding some missing parts of another simple node application to do search on Confluence and summarize top 10 results. Again, most participants had not finished it. While I'm not a developer per se, I have system and network administration background. I'm in system reliability engineering, cloud security. I know my shell scripting. I know Python, of course, but I'm not comfortable with Java programming. However, here's what happened. PR reviews are part of my daily chores. I have this huge compiled PR review checklist in a markdown file, and I just tell the agent to check this or that PR against the checklist and report potentially critical issues. Takes it maybe 5 minutes top. After that, I still have to eyeball the logic myself for half an hour, but that's a different story. And the conflict search summary, I managed to have it in 5 minutes by giving the agent the address of the corporate Confluence instance. That's it. I think I had my Zen moment there at the conference about the new paradigm. I'm not yet entirely sure what it is, but I have an idea about what it's not. It's not about writing custom agents for every task. Of course, this will be necessary in special cases, but a waste of effort for many more. It's not about massaging prompts. That's like building sandcastles on the seashore. The next model update washes everything away. It's not about vibe coding. That's just an early adopter's toy. If something can be coded by an AI, everyone and their grandmother can do it today. Well, almost. But tomorrow, AI will do it autonomously. API stability? Problematic since proper software engineering was replaced by Agile. Also, the timelines speed up from years to months. I have this hypothesis that computation overhead, tokens economy, model selection, all will become irrelevant very, very soon. AI will become cheap, it will be everywhere. If something can be done by AI, why code it and compile it? Maybe instead of trying to build a Java app for everything, we'll leverage what AI agents are actually good at. Of course, AI will make mistakes, and the responsibility is always on humans, so supervision is obligatory. To see how this could work, I tried to automate some of my real-time tasks using an LLM-based AI. Spoiler, here's what I'm using an agent for. Peer reviews, I already mentioned that. Coding, everybody tries this. Some like it, some hate it. I find it very problematic. And errors are not the only problem. Still, I do frequent assisted code self-reviews. Config rules deployments on AWS. This task is a mess because the tooling is old, the procedure is complex, errors are frequent and semi-random. Strangely, or maybe not, this is the task I've had most fun and most success automating with an AI agent. I'll tell you about it in more detail shortly. Documentation, mostly automated creation, assisted search and consultation, just works. Working notes. In fact, this was the first thing AI helped me with. I keep this work journal in Markdown, where every task I do is documented in just enough detail for me to quickly go back and check the procedure, the result, the linked tickets, things like that. AI has almost fully automated task management and notes taking for me. And this presentation is also a simple Markdown file that AI agent has formatted following the present term documentation, not without some errors. I first started with this simple shell script I called Tails. We didn't have agents back then, but we had access to OpenAI API. I wanted a command line chat, but there was no context persistency. So this script kept a history file and fed parts of it back with user prompt for context. It also inserted text from files or clipboard so I could review some code and ask for suggestions. Uh, this was not an agent, and though I thought about it, I never added any agent-like functions. Good for me because eventually agents arrived. Amazon Q was the first CLI tool I had access to. It was supposed to be a coding assistant with VS Code integration, etc. I use Vim. Turned out Amazon Q is more useful as a general purpose agent. There were some problems though, for which I tried to find the quickest and simplest hacks possible. Just before yesterday, Amazon announced Cairo, the new generation of its coding assistant, and it fixes some of the problems I have hacked around. Still, I'll show you what I did. The first problem I had with Amazon Q agent was no constant persistency across sessions. There's the session save and load functionality, but it's manual, it's tedious, it produces barely readable JSONs. Instead, I wrote an elaborate set of instructions for the agent in a simple Markdown file. Those instructions were very simple at the beginning. Keep chronological order, create a section for current task, note executed commands verbatim as code blocks, etc. The list grew over time to include instructions on agent's autonomy, which actions require explicit user confirmation, how directories should be checked for repo data, current branch, uncommitted changes before making any modifications, etc. It also included some tools the agent had to use often, like push something to clipboard or read from it, or work with GitHub PRs. Far from ideal, but it mostly worked. Once reminded to reread the journal, the agent continued quite reliably to take notes and use those tools. Another annoyance was the awkward tool permission system. Amazon Q kept nagging for authorization on every tool use until I opted to trust the tool. Once trusted, the agent would use that tool at its own discretion. But a tool in Amazon Q terms has a very broad scope. For example, writing to any file with fswrite tool takes one trust approval. And that only until the next session when the nagging restarts. Far from ideal, but a couple of simple configuration changes can permit non-destructive tools forever, no nagging anymore, and limit fswrite to certain file system subtrees. Something like this. Amazon Q has ample context size. This is both a blessing and a curse. It works great for short tasks, but on long ones, the agent tends to get forgetful and ignore instructions, even before the dreaded context overflow event. Luckily, a quick agent configuration permits adding a custom system prompt that will be prioritized through the session. This is how it looks like. I also needed some kind of automatic timestamp logging of user prompts, agent responses, and most importantly, executed commands. Adding several instructions to the custom agent configuration forces the agent to keep such a log. It's not bulletproof, but it's sufficient in my case, and it works quite reliably for such a primitive hack. The next one was tricky. To run long multi-stage deployment tasks, I needed Amazon Q to initiate Jenkins builds and check back regularly. Cairo, the new generation agent, has added this functionality, but Amazon Q was strictly interaction-driven agent. I first instructed the agent to run sleep commands, but this blocks the chat until the wait finishes, and periodic logouts break this system. If I started scripting around this problem, that would be like building a Java application to summarize Confluent search results. I didn't want to do that. So I opted for a simple hack. Here's how it works. An additional set of instructions in the customized system prompt teaches the agent about ongoing tasks that should be checked back with some periodicity, say every 5 minutes. It also reminds the agent to always go check the list of those ongoing tasks before processing any user prompt. And finally, it also tells it to check the timestamp log for previous check on the same task. It sounds complicated, but it works. Amazon Q can now do timed notifications for the user or check in and go with deployment from time to time. Of course, I still have to interact with it somehow for it to work, but at least I can continue to work on other tasks while waiting. The final problem was very easy. For complex tasks like deployment, my agent required access to some internal documentation. Well, no hack required here. Amazon Q already had this knowledge system where it indexes a given file or directory, and the index stays with the context. With those configurations and hacks, I approached one of the team's larger tasks, weekly config rules deployment. It is a procedure with 9 separate stages, each capable of failing quasi-randomly for a number of different reasons. Worst part is some of the more rare errors tend to leave the system in such a state where fixing it is relatively easy, but even a single retry compacts the problem into a mess that takes a day to undo. Yes, it's ugly. One word, legacy. This is a report based on 2 automated deployments already done. The agent, slightly customized as described above, used only markdown files for initial instructions, planning and status tracking, autonomously consulted the documentation for command templates, etc., had 0 additional scripting beyond existing Jenkins pipelines that humans also use. First, it planned the deployment step by step and requested human approval as instructed. Next, it did initial status check to ensure the previous deployment left the stacks in proper condition and requested human approval to proceed with the deployment itself. The first deployment was interrupted a lot. Every error was inspected by the agent, and a list of retriable errors with signatures was established in cooperation with the user. At each step, the agent did periodic checks following the simulated asynchronous check protocol, all while assisting with other tasks, retried the deployment if it recognized a retriable error, or did an automated investigation and consulted the operator with a full report at hand. Eventually, the agent was capable to continue without human interaction. Next full deployment, only general supervision was required. Did it go smoothly? Nope. At least once the agent made a very childish mistake. Instead of the planned Jenkins pipeline, it tried to trigger an older one that it found in the documentation. Did it solve all the problems with these deployments? Nope. The process still took more than a full working day in total. But where before, one of the team would have to constantly babysit the process, search for error signatures and retry manually, now only minimal supervision was required. I usually give my customized agents a touch of personality. This one is HAL 9000 from the Space Odyssey. Just for fun, after the second deployment, I asked it to reformulate the 3 laws of robotics for today's context. An AI agent may not execute destructive operations without explicit user confirmation. An AI agent must obey user directives except when it conflicts with the first law. And an AI agent must preserve its operational integrity and keep logs. Funny, but also quite relevant. However, this made me think about the new paradigm again. We remember what Asimov's iconic series was about. Once we transcend beyond programming algorithms to machines that can't be programmed but are taught, trained, there's no reliable way to enforce those laws anymore. Predicting future is easy. It's accepting the prediction that's the toughest part. So back to the hypothesis that AI as we know it must become very, very cheap and available on every computer. What then? In 10, 20 years? Some changes become automatically unavoidable. For example, average users will gradually stop using software directly. They will interact with the local AI. The AI in turn will orchestrate processes, interact with software, interact with remote AIs, and provide the user with a result and a report. No more crusades for intuitive interfaces. They won't matter anymore. In 5 years, you will be able to call home. Not call someone at your home, but call your home, literally. I don't know why. Maybe you'll simply be feeling lonely at that particular moment. This is the fun part. Is the tough one for us who work in IT. Why automate something if it can be done by an AI a million times over if necessary, tirelessly, and with flexible error recovery? Programming will become the new photography. Photography used to be a huge thing once, an art, a craft, and a technical expertise all in one. A well-paying job and a creative occupation. Today, everyone has 3 or 4 cameras on their smartphone alone, and gigabytes filled with photos. Nobody gets paid for it. Hell, we pay for storing extra photos in the cloud when those gigabytes fill up. Developing software will soon be like that. Of course, someone will still have to do the real coding, system programming, database programming, etc., but that software will not be for human use. They will be hidden foundation for the AI ecosystem. But this is not the scariest part yet. Security is going to be a very different game, and we're going to lose at it a lot. We'll try to make every operation transactional to be able to revert. We'll use immutable systems with version state. If there's still something left that's not as a code, we'll make it and version it. But the traditional approaches to security will start to crumble anyway. Today's IT security puts a lot of trust on limiting the user. They can't run that or that program, for example, but we give the user an agent capable of writing half of those programs on the fly, or even imitate them without writing the code itself. When every wearable computer has AI with potential to analyze video and audio in real time, capture glimpsed passwords, credit card numbers, read lips, how does one really isolate computers? An isolated AI might decide to ask an AI on another computer by blinking a couple of pixels on the screen, or by hissing with the system speaker, just so. Also, CVEs might have to be closed from public, because automated flexible exploiting is near instantaneous and cheap. Patching is still slow and expensive. Finally, once AI is wearable, smartphone sized, autonomous killing machines will be the new Luigi Mangione. We'll start wishing for a Zimos version of the future, where we could be heading right into Daniel Suarez' demon. Yet, as a positive and hopeful final note, I had a real surprise when I was finishing the day after the deployment, and I teased this agent with my usual thematical joke. I did not instruct my agent to do this. Thank you.